Good afternoon everyone. I Harish Sen welcomes you to Sri Chaitanya Academy. We bring you today another live session and this is the third lecture in our transition course. So in the first two lectures we have talked about functions. So in the first lecture we talked about functions, what functions are, right? In the second lecture we talked about some two special functions, right? And what were the two special functions? There were the log functions and the exponential functions. So now we move on to the next part, right? What is the next part? Now we will move on to trigonometry. Okay, trigonometry is a very important and essential part, okay, of basic mathematics, right? It is used too much in physics, right? So the knowledge of trigonometry is very important. Okay, so we will cover what is useful in trigonometry here. Okay, so let's start without wasting any time. So first of all, let's start with the basics. Okay, so what do we have here? So let's understand that. Let's say that if I take a rope, okay, let's suppose if I take a rope, let's say if I take a rope of length L, okay, if I take a rope of length, let's say R, okay, and I tie the rope to one end. Let's suppose if I have tied the rope to one end, right? And let's suppose if I have tied you to the other end of the string, okay? What is this? This is a hinge, right? This is fixed here. And I have tied you to the other end of the string, right? Now what you will do? You want to go away, no? You want to get away. So what is the farthest distance you can go, right? This is the farthest distance you can go, and at this point the string will be tight, right? So I will be able to move in this region, no? In this circle. Correct? I will be able to move in this region only, no? Correct? I will not be able to go further than this. Okay, so when I am not able to go further than this, right? What is happening? Let's suppose I will form an arc. So basically this is a circle, but let's suppose we will be also forming an arc. So what does the arc look like? So let's say I am able to move from here to here. Okay, so my string will also come here. So I am able to move, right? So this is some arc which is formed. Okay, what is this? This is an arc. And I have moved some angle theta, right? I have moved some angle. What is this? An angle rotated, right? In class 10th, you might have known that what is an angle? It is an angular rotation, okay? The distance calculated in terms of angle, right? So now when I have this angle here, this is theta. So how can I find the length of this arc, right? So what do I want to find? I want to find the arc length. Okay, so the formula for arc length, that's all right. The formula for arc length is very simple, and it is given as arc length is equal to first of all, arc length should be equal to the length of the string which we are taking, right? What is the length of the string? The length of the string is this r into the angle rotated, okay. So what is arc length equal to? Arc length is equal to r, that is the length of the string through which I tied, right? I am tied, and the angle rotated. Now it is very important to know that this, okay, so let's find the unit. So this arc length is measured in meters, radius is also taken in meters, but what is the angle? So angle is, so till now what do we measure angle as? Degrees, right? But here the angle is measured as radians. So now what is radians? Okay, what is radians? So let's suppose if I want to let's suppose measure the length of this pen, right? Yes, the length of the pen is around, let's say, 10 centimeters. Okay, but let's suppose if I don't want to tell the length of the pen in centimeters, I want to report the length of this pen in meters, right? So yes, I can report the length of this pen in meters also. I can also report the length of this pen in kilometers also, right? But what is the most appropriate unit? Centimeters, right? Similarly, for this angle, yes, we can measure the angle in, okay, angle can be measured in first of all degrees, and we can also measure it in radians. Okay, I can measure my angle in degrees as well as radians. Okay, but the SI unit for this is radians. We use radians as the SI unit. So this is very important here. So now till now what have we studied? We have studied till now in degrees, right? So now I should know the conversion from degrees to radians and radians to degrees, vice versa, right? So conversion of degree to radians and vice versa. Okay, so now I will let's take a simple example that, see, when I start from here, okay, let's suppose I am standing here, okay, I start from this point P, okay, I start from this point P, and this is the center O, okay, of a circle. I start from here and I rotate this complete circle and I come back to the starting point, right? So can I say that if I start from here and I come back, if I start from here and I come back to this point, can I say that the angle that I rotate is 360 degrees, right? So I can say in one rotation, right, in one rotation the angle rotated is 360 degrees, right? But now what are we doing here, right? We are finding, right, what we are doing, we are finding how much degrees is how much radians, or how much radians is how much degrees. Basically we are finding the conversion here, correct? So now, so 360 degrees is equal to 2 pi radians. This is very useful and this is very important. Okay, if you know this single thing, yes, you can make the conversion very easily. What? 360 degrees is equal to 2 pi radians. So now, how do we know 360 degrees is equal to 2 pi radians? It is the same thing that 100 centimeters equals to 1 meter, no? How do you know that? Okay, so these are the units which we have made for ourselves so that it becomes easy for us to do the calculations and report the answers. So 360 degree equals to 2 pi radians. Okay, so now let's do one thing. Okay, so let's write here that 360. So first of all, let's do one thing. Degrees to radians. Okay, that is what we are doing. We are converting degrees to radians. So I know that 360 degrees is equal to 2 pi radians. So I will ask that 1 degree is equal to how many radians? Okay, what is this? This is a simple unitary method. Okay, we are basically doing simple unitary method here, right? What I am asking you that if 360 degrees equals to 2 pi radians, 1 degree is equal to how many radians? So how do you do this? How do you solve this? 360 upon 1 is equal to 2 pi upon, instead of this I will take x radians, okay, x. So what I say, x is equals to 2 pi upon 360. So this will be pi by 180. So what can I say, that 1 degree is equals to x, so this much radians. So what can I say? I can say that 1 degree is equal to pi by 180 radians. Very important. That 1 degree is equals to pi by 180 radians. So let's say if I ask you a question that okay, how much is 90 degrees in radians? So what I will say? I will say that 90 degrees, what can I write 90 degrees? I can say 90 degree is 90 into 1 degree. Can I write this? Right? 90 degrees 90 into 1. So I can say 90 into what is 1 degree? 1 degree is pi by 180 radians. Pi by 180 radians. So this will be equal to how much? This will become pi by 2 radians. Okay, clear? So this is how you can easily solve that 90 degrees equal to pi by 2 radians. So what I am using basically, I am using 1 degree is equal to how many radians? Let's suppose if I want to do the vice versa, okay. So let's first find how to convert degree into radians, right? So simply, if I have this first question, right, first question 160 degrees, right, so 160 degrees I can write 1 degree into 160, correct? Simply I am saying 160 degrees is 1 degree 160 times. So this will become how much? What is 1 degree? 1 degree is pi by 180 radians. So I can say pi by 180 radians into 160. So 0 cancels with 0, 2 9s are 18, 2 8s are 16. So this will become 8 pi by 9. Correct? Let's solve the second question here. So if I want to solve the second question, it will be how much? 135 degrees. So I can say 135 degrees is 1 into 1 degree into 135, right? And this will be equal to how much? Pi by 180 into 135. So 5 3s are 15 and 5 6s are 30. This will become 5 2s are 10 and 5 7s are 35. 3 1s are 3, 3 2s are 6 and 3 9s are 27. 3 4s are 12 and 3 3s are 9. So this will be equal to how much? This will be equal to 3 pi by 4. Okay, so I can say that 135 degrees is 3 pi by 4 radians. Okay, so please try to solve these two questions. Okay, 135 degree and 65 degree. Just try to solve this 75 degree and 65 degree on your own. Okay, same thing. But now let's suppose, what if I want to convert degrees into radians or radians into degrees, because we know the conversion of radians into degrees into radians, right? But what if I want to do the opposite? Okay, so now understand. Okay, what we'll do, first of all, we know that 360 degrees is equal to 2 pi radians, right? We know this 360 degrees is equal to 2 pi radians. So what can I say? X degree is equal to 1 radian, right? What did we do before? Before we found 1 degree, right? Now, so now what can we do? We can say that 360 upon x is equal to 2 pi upon 1. So this x will become 360 upon 2 pi. Correct? 360 upon 2 pi. This will become 180 upon pi. So basically what we are getting here? We are getting that 1 radian is equal to 180 upon pi degree. 180 upon pi degree. Okay, so this is the new thing we should use here, right? If you go back, right, I can say that 1 degree is pi by 180 radians. Similarly, 1 radian is 180 by pi, the opposite of this, right? So now what can we do here? So let's write this. Okay, let's solve this question. So if I want to solve this question, what I'll do? We'll use the same formula, right? So 60 degrees, right? So what do I want to do? Convert angle from radians to degrees. Okay, I want to convert from radians to degrees. So what do I have? I have 5 pi by 6 radians, right? So what can I write this? I can write this as 5 pi by 6 into 1 radian, right? This will not make any difference here. 5 pi by 6 will become 5 pi by 6 into 1 radian. Now, what can I write this 1 radian as? I can write 5 pi by 6 into what is 1? So, let's write 1 radian is equal to 180 by pi degrees. Just substitute it here. So, 180 by pi degrees. So, this pi cancels with this pi, 6 3s are 80 and 0. So, this will become how much? 150 degrees. Okay. So, this is my final answer, 150 degrees, option number 4. Okay. So, now you should understand that what we are doing here, okay, to convert from degrees to radians and radians to degrees. Okay. So, now, okay, now always I will not be able to calculate this, no. So, there is a simple trick. There is a simple trick that we are going to use. Just 1 minute. Okay. So, now I will give you a formula that if I have degrees, if I have something in degrees, and if I want to convert that to radians, so if I have something in degrees and if I want to convert that into radians, what should I do? Just look here, if I have something in degrees and if I want to convert into radians. So what did I do? If I have something to degrees to radians, look here, right? Basically what I am doing, I am multiplying this 90 into pi by 180, no? I am just multiplying it by pi by 180. If you look everywhere, 160 into pi by 180, 135 into pi by 180. So just multiply this by pi by 180. Okay, you will be able to convert your degrees to radians. But what if I want to do the opposite? What if I want to do the opposite? If I want to convert from radians to degrees, if I want to convert from radians to degrees, what we have done? From radians to degrees, look here, 5 pi by 6, 5 pi by 6 was here, I have multiplied by 180 by pi. I will multiply it by 180 by pi. So just multiply it by 180 by pi. Simple as that. Okay. So this is how you can convert from degrees to radians and radians to degrees. Clear? So this is that easy. Now let's move forward. Okay. So now we'll move on to trigonometric ratios. Okay. I know you have done trigonometric ratios in your class 10th, right? So we'll build upon that only. Okay. So what are trigonometric ratios or T ratios, right? So in a right angle triangle, okay, this we have a right angle triangle here, right? This is a right angle triangle. And you know what, why this triangle is a right angle triangle? First of all, what is a triangle? A triangle is something which has 3 sides, no? Right? A polygon having 3 sides. So in this 3 sides, why it is right angle? Because one of the angle is 90 degrees. One of the angle is 90 degrees. And let's say one angle is given, theta is given to us. So what is this angle? This angle will become 90 minus theta. This angle will become 90 minus theta. Okay. So now we have the angles also. Theta, 90 minus theta and 90. So basically in a right angle triangle, if I give you one angle, only one angle. Let's say I tell you that in a right angle triangle, okay, one angle is 60 degrees. Okay. So can you find all the 3 angles? Right. What can I say? That if in a right angle triangle, if one angle is 30 degrees, right, since it is a right angle, other angle will be 90 and the last angle will be 90 minus 30, that is 60 degrees. Okay. So please pay attention here. Okay. So in the right angle triangle, we have this perpendicular base and hypotenuse. Now perpendicular base and hypotenuse all depends. What they depend upon? They depend upon what are you taking theta as. Okay. So let's, in this question, let's say if I have this triangle, okay, and it is right angle at this, okay, let's say this is A, B, C, and if I have this as theta, okay, if I have this theta, then with this respect to theta, right, the opposite side, yes, the opposite side is known as the perpendicular. Okay, the opposite side, what is this? This I can say is the opposite. Okay, so this is the opposite, or I can say this is my perpendicular. Perpendicular with respect to what? Perpendicular to with respect to this. And what is this? Adjacent, right? What is this? This side is CB. This side CB is near this angle theta, right? This side CB is near this angle theta. That is why this is known as adjacent. Or I can say base. And lastly, the longest side we know is the hypotenuse of the triangle, right? The longest side is known as the hypotenuse of the triangle. So this is very important here. So now what I am trying to say that, let's suppose if I give you some other triangle, okay? Let's say if I give you some other triangle, and let's make a triangle here. Okay, let's make a triangle here, and in this triangle, let's say if I tell you that if this is angle theta, let's say this is A, this is B, this is C. Okay, now in this triangle ABC, can you please tell me what is the adjacent, what is the base, and what is the hypotenuse? Or what is the perpendicular and what is the base? Right, so always the longest side is the hypotenuse, right? So longest side is the hypotenuse. Okay, now what is the base and what is the perpendicular, right? So to calculate the perpendicular, like what is perpendicular? For the theta, from the theta, you go to the opposite side. You go to the opposite side. So this is my opposite side, okay? This is my opposite side, and opposite side is my perpendicular. Okay? You might think that, okay, this should be the perpendicular, AB. No, here the perpendicular is BC. And what is the base? The base is the side adjacent, right? To this theta, this is the side adjacent, right? This is the adjacent side and this is the base here. Okay, so please keep this in mind. This concept is very useful because usually students make like mistakes in this. Okay, so in this triangle, what are the things, trigonometric tree ratio that are defined? Sine, cos, tan, cosec, sec, cot, right? So what is sine theta? Sine theta is perpendicular upon base. What is cos theta? Base upon hypotenuse. And what is tan theta? Perpendicular upon base. Okay, so these are the three ratios which we know. Okay, now what is the opposite of sine? Opposite of sine is cosec, right? Opposite of sine is cosec, right? What is opposite of tan? Opposite of tan is, okay, so opposite of cos is sec and opposite of tan is cot, right? 1 upon tan will give you cot, 1 upon sine will give you cosec, and 1 upon cos will give you sec. Okay, so if you know this three ratios, 1, 1, 2, 3, you can find the other three t ratios. Okay, so I hope this is easy for you. Okay, let's move forward. So let's solve this question. Find the value of hypotenuse. Okay, what I am trying to find, the value of the hypotenuse. So how will you find the value of the hypotenuse in this case, right? We will use Pythagoras theorem, right? And what is Pythagoras theorem? Pythagoras theorem is, for a right angle triangle, we define a Pythagoras theorem. We say that hypotenuse square is equal to base square plus perpendicular square. Okay, in this question, what is the perpendicular? This is the perpendicular P, right? This is my base 4 and this is the hypotenuse. So this is my Pythagoras theorem, right? Pythagoras theorem. So let's use the Pythagoras theorem. So I can say h square is equal to, now what is b square? B square is 4 square plus what is p square? P square is 3 square. So this will give me 16 plus 9. 60 plus 9 is 25. Right? So hypotenuse square is equal to 25. So what is hypotenuse? Hypotenuse is equal to 5. Okay? Hypotenuse is equal to 5. So what is the answer? Third option is the correct answer. Okay? Clear? Let's move forward. So now we'll move on to the trigonometric identities, right? Why are they identities? Because these identities are always true. Remember, what is an identity? An identity is something which is always true. Okay, so what are the three identities? Okay, there are three identities. First identity is sine squared theta plus cos squared theta is equal to 1. Second is 1 plus tan squared theta is equal to sec squared theta, and the third one is 1 plus cot squared theta is equal to cosec squared theta. Okay, so I have talked what sine is, what cos is, what tan, what cosec, sec are, right? They are the t ratios, and we have three identities. Okay, what are identities? Identities are something which are always true. Okay, always true. Clear? So now we will move forward. Okay, so now values of trigonometric functions for common angles. Okay, so now what we are going to do next? Okay, we are going to write the trigonometric values for some angles. Okay, and trust me, this is the most important thing in trigonometry. Okay, this will remain with you in physics, I am saying, okay, till the end of your class 12th. Why? Because in each and every chapter, okay, you will be using these angles. So what I want you to please remember all of them. Okay, remember all of them by heart. Okay, I should ask you any angle, you should know the answer. Okay, you should not think also. So let's write the angles. Okay, so what are the angles for which you should know the answer? 0 degree, 30 degrees, then 37 degrees, 45 degrees, 53 degrees, 60 degrees, and 90 degrees. Okay, these are very important angles. Okay, these are the most important angles, and if you know these angles, you can find value for any other thing. Next is, so what are the sine, cos, tan, cosec. Okay, so these are the angles for which you're going to find. So let's write. Okay, what is sine 0? Sine 0 is 0. What is sine 30? Sine 30 is 1 by 2. Right? Now we'll come to 37 degree. Okay, what is sine 45? What is sine 45? Sine 45 is 1 by root 2. Okay, we'll come to 53 degree. What is sine 60? What is sine 60? Sine 60 is root 3 by 2. And what is sine 90? Sine 90 is 1. Now, if you look at 37 and 53, right? So, what is 37 and 53? 37 and 53 are complementary to each other. When I say complementary to each other, what do you mean by that? I mean that 37 plus 53. What is 37 plus 53? This is equal to 90 degrees, right? So they are complementary to each other. So whenever you see 37, right? Whenever you see 37 or 53, right? What do? You just make a triangle, okay? Just make a small triangle here. And let's say this is 37. Let's make it somewhere here. Okay, let's make it somewhere here. This is 90. Let's say this is 37. Right? This will be 53. So whenever I see something like this, yes, I will remember the triangle of 3, 4, 5. Okay? After 3 comes 4 and after 4 comes 5. Okay? So if you are able to make this triangle, you can write answer for each and everything. Okay? So let's come back here. That okay? So what is sine 37? So I am talking about 37, right? For 37, what is the opposite? Opposite is this or perpendicular is this, right? And base is 4. So what is, and this is hypotenuse. So what is sine 37? perpendicular upon hypotenuse, that is 3 upon 5. So this will be a 3 upon 5. Similarly, what is for 53? For 53, this is my perpendicular and this is my hypotenuse. So this will become 4 upon 5. Okay, clear? Let's move forward. What is cos 0? Cos 0 is 1. What is cos 30? Cos 30 is root 3 by 2. What is sine 37? Sorry, cos 37. So for cos 37, right, what is cos 37? For cos, this we will say base upon hypotenuse. This is 37. For 37, this is the base and this is the hypotenuse. So this will be 4 upon 5. Cos 45 is 1 by root 2. 53 will become 3 upon 5. How 3 upon 5? Because for 53, this is the base and this is the hypotenuse. So 3 upon 5. Cos 60 is 1 by 2 and cos 90 is 0. Now what is tan? Tan is sine upon cos. What is tan? Sine divided by cos. So just divide them. So 0 upon 1 will give me 0. 1 by 2 upon root 3 by 2 will give me 1 by root 3. 3 by 5 upon 4 by 5 will give me 3 by 4. We can also confirm this by, from this triangle, for this triangle, this is the perpendicular, this is the base. Tan is perpendicular upon base. So 3 upon 4. 1 by root 2 divided by 1 by root 2 will give me 1. 4 by 5 upon 3 by 5 will give me 4 by 3. And root 3 by 2 upon 1 by 2 will give me root 3. And 1 by 0 will give me not defined. Okay, this is not infinity, this is known as not defined. Okay, we cannot define it. Okay, so we know for sine, cos, tan. Okay, now I will give you an exercise, a simple exercise. You try to find for cosec, sec, cot. Okay, for cosec is 1 upon sine, right? What is cosec? 1 upon sine, 1 upon sec, and 1 upon tan. Sorry, sine, cos, tan. Okay, this should be cos. Okay, so please try to do this exercise. Okay, I should write your angle. Okay, I should write an angle theta. Theta should be written because cos itself doesn't mean anything. Okay, these are all the angles for which we have found. Okay, so this table is very useful. Okay, what I have written on board is very important for you for physics. Okay, if you know this much, right, then only you will be able to solve questions fast. Otherwise, you will be stuck, right? So I want you to make this table, okay, on a piece of paper, okay, and stick it in your room wherever you study. Correct? This will be very helpful for you in your future also. Next. So I have this question. Okay, so I will give this question as a homework for you. Please solve this. Try to solve this. Okay, let's solve this question. So it is given, if sine theta plus cos theta upon sine theta minus cos theta is 7 by 3, right? Then tan theta is. So let's solve this. So what I'll do, sine theta plus cos theta upon what is given, sine theta minus cos theta is equal to 7 by 3. Right? What I'll do cross multiplication. So this will become 3 sine theta plus cos theta is equal to 7 sine theta minus cos theta. I'll multiply this inside. So this will become 3 sine theta plus 3 cos theta is equal to 7 sine theta minus 7 cos theta. Right? So this will become how much? This 7 will come this side. So this will become how much? This will become 7. This will become 10 cos theta is equal to how much? This will become 7 minus 3 is 4. 4 sine theta. So I will get 10 upon 4 is equal to tan theta. So this will become 2 and 5. So what is tan theta? Tan theta will become 5 by 2. So this is the correct option here. Clear? I hope this is clear to you. Okay, in this question, find x, y and perimeter of the triangle show. Okay, so now for this triangle, if you see, right, let's mark this triangle ABC. Okay, so let's say this is my A, this is B, and this is C. So when I look at this triangle, what can I say? Right, I can say that it is right angled at B, right? Why it is right angle at B? At B, I have the angle to be 90 degrees. This is 90 degrees. Correct? Now, we know that if one is 53, what is the other? The other side will be 37 degrees. Right? If one is 53, other will be 37. Why? Because I told you that 37 and 53 are complementary to each other. Okay, these small things you should remember. Okay, so now I have this triangle. So x, y. Now, so if you look at this in a right angle triangle, in this triangle, what did I tell you? That opposite to 37, right? This triangle of 3, 4, 5. This triangle of, this is 37, this is 90. So always remember this triangle of 3, 4 and 5. Correct? So opposite to 37 we have 3. Opposite to 37 we have 3. Right? And near 37, that is the adjacent, is 4. If you compare these two triangles, right, you will be able to find. So what can I say? Simply I can say that x is equal to 3, y is equal to 4. Y is equal to 4. And what is the perimeter? Perimeter is sum of all the sides. So the perimeter of the triangle, perimeter P, is equals to 3 plus 4 plus 5. So this will be equal to how much? 4 plus 5 plus 4, 9, and 9 plus 3, 12. So this is 12 is the answer, 12 centimeter. Okay, clear? So let's move forward now. So there are few important trigonometric formulas that you should know. Okay, when I say formulas, right, this, see, trigonometry in trigonometry there are so many formulas, okay, that you should know. In math there are too many formulas. In physics there are limited number of formulas which a person should know. Why? Because that makes the question easier for him. Okay, will not be going on and deriving each and every formula. Okay, we'll do some questions to understand why they are important. But now let's start with the first sum and difference formula. Why this is sum and difference formula? In this it is given sine A plus B. Some angle is given. So what kind of formula is this? Okay, so let's say if something is given like this, okay, sine, let's say 75 degrees given. Sine 75 degrees given. Do I know the value of sine 75 degree? So I will go to my table, no? If I go to my table, do I see 75 anywhere? Do I see 75? No, I don't see any 75 degree here. So this will be an issue for me, no? I will not see. There are so many angles from 0 to 90. I will not go and learn each and every angle. Yes, what did I tell you? This table is sufficient for you. So if this table is sufficient for you, how will I be able to find 75 degree? Because 75 is not here. So I will use sum. Okay. So what do I know? 0, 30, 37, 45, 53, 60, 90. So let's make this 75. Can I make this 75 from all the angles which I know? Right. So can I write this? So I can write this as sine 45 plus 30 degrees. Can I write this? Yes, I can write this. So now I know sine 45, I know 30. So if I use the first formula, sine A plus B, what is sine A plus B? Sine A plus B is sine A cos B plus cos A sine B. So the formula I will use is sine A cos B plus cos A sine B. What is sine B? Sine B is 30 degrees. Right? So sine A cos B plus cos A sine B. Once I have this, what is the value of sine 45? Sine 45 is 1 by root 2. What is sine 30? Cos 30 is root 3 by 2. Plus What is cos 45? Cos 45 is 1 by root 2. And what is sine 30? Sine 30 is 1 by 2. Right? So when I have this, what can I say? This will become root 3 plus 1 by 2 root 2. Okay, so this is the value of sine 75. So I hope you understand the importance of these sum and difference formulas. Okay, if I have something different, no, let's suppose if I want to calculate, I can also use this formula, no, right? If I want to calculate sine 15, let's suppose if I want to calculate sine 15, okay, if I want to calculate sine 15, so how will I calculate sine 15? Sine 15. So what can I write sine 15 as? I can write sine 15 as sine 45 minus 30, right? Sine A minus B. I will be easily able to calculate sine 15. Okay, and if you look in this table, there is no sine 15, right? 0, 30. Clear? So this is how you will be able to calculate the angles which you don't. So these are the general angles, okay, standard angles. 15 is not a standard angle, 75 is not a standard angle. Okay, so now you should understand the importance. Okay, so sine A plus B is sine A cos B plus cos A sine B. Then what is sine A minus B? Sine A minus B is sine A cos B minus cos A sine B. Okay, just if you want to remember these two formulas as one, you can just understand that, just substitute that plus with minus, this plus with minus. Okay, you will get your answer. Next, cos A plus B. What is cos A plus B? Cos A cos B minus sin A sin B. And what is cos A minus B? Cos A cos B plus sin A sin B. Here it is opposite. If I have a plus here, I will have a minus here. And if I have a minus here, I will have a plus here. Okay, so simple. Otherwise, each and every term is same. So basically, we have only two formulas here, no? Sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A sin B, sin A cos B minus cos A sin B. What is cos A plus B? Cos A cos B minus sin A sin B, and cos A minus B is cos A cos B plus sin A sin B. Okay, so effectively we have two formulas with some tweaks. And now what is the third formula? Tan A plus B. Tan A plus B is tan A tan B, tan A plus tan B upon 1 minus tan A tan B. So now what about minus? So if I have a minus, I will just substitute this plus with minus and this minus with plus. Okay, so this is my third formula. So these three formulas can be combined into three formulas, 1, 2 and 3. Clear? See, these are some just small tricks, but eventually you will have to remember them. Okay, let's move forward. Now this is sine C plus sine D. Okay, here the angles were both in addition. Here the angles are not in addition. Here it is something written as, let's say I want to find sine 30 plus sine 45. Okay, I have something like this. Okay, then I will be using this. Okay, but this will not work here. Okay, something like this. Okay, this is just an example here. Okay, so sine C plus sine D. What is sine C plus sine D? 2 sine C plus D by 2 cos C minus D by 2. What is sine C minus D? 2 cos C plus D by 2 sine C minus D by 2. Okay, what is cos C plus cos D? 2 cos C plus D by 2 cos C minus D by 2. And finally, cos C minus cos D equals to minus 2 sine C plus D by 2 cos C, sine C minus D by 2. Okay, so how can you remember? 2 SC. This is 2 CS. This is 2 CC and minus 2 SS. Okay, so this is how I remember this. This is the short form which I use to find the answers here. Okay, if I just keep this in mind, 2 SC, 2 CS, 2 CC, 2 SS. Okay, clear? Let's move forward. So find the value of sine 75 plus sine 15. Okay, so find the value of sine 75 plus sine 15. So what do you think should I use? Okay, so can I use the first formula here? Sine C plus sine D. So I'll use the formula for sine C plus sine D. What is this? 2 SC, no? Sin C plus sin D is 2SC. 2SC. So I'll use 2 sin C plus D by 2 cos of C minus D by 2. Right? So what do I have? I have 2 now. What is this? This is 75 and this is how much? This is 15 degrees. So I'll substitute this 2 sine. Okay, this will become how much? 75 plus 15 divided by 2 and this will become cos 75 minus 15 divided by 2. So this will become how much? 2 sine, right? This will become how much? 75 plus 15, 90 by 2 will become 45 plus this will become, sorry, this is cos, this will become 75 minus 15 is 60 by 2 is 30, right? So this will become 2 into 1 by root 2 into, right, what is cos 30? Cos 30 is root 3 by 2. So this 2 cancels with this 2 and this will become under root 3 by 2. So fourth option is the correct answer. Okay, clear? So now this is these are some questions which I have given you for your practice. Please try to attempt them. Okay, they can all be done by the formulas which have been given here. Okay, so now I end this session here. Okay, we will continue with the remaining part. Okay, there are some things which I have to do, but I will continue with them in the next class. Please, okay, same time tomorrow at 4 o'clock. Please join. Okay, we will continue with this. Okay, and this is a 3-week long transition course. Okay, and this will help you to make a proper transition from your 10th to 11th, right? So this is why we are taking this course. Okay, please join our channel, Telegram channel, where we post all the worksheets which we give you. Okay, and scan this QR code. Okay, any doubts which you have, right? Any academic, non-academic doubts which you have, just scan this QR code and our team will connect with you. Okay, so thank you for joining and we'll meet tomorrow again. Thank you everyone.